Welcome back. If you need to copy the outline, go ahead and pause the video now so that you can do so and come back and join us when you're ready. All right, so today we are going to talk about properties of exponents. This is a topic that a lot of students struggle with for some reason, and it's really just a practice makes perfect. So you'll notice in your homework packet, there's only, 8 or 10 assigned problems for tonight, but if you need more, I have made copies of, there's more in OneNote, so feel free to go do more practice. It's just there if you need it. So let's start off with a couple basic examples. That's why I left this blank up here. So a couple years ago, I had a student, and her mom, they made up this mnemonic device to help her remember the exponent rules, and I really liked it, and I thought it was very helpful. So let's go ahead and start from the beginning. M and A. So what that's telling us is that when we multiply, we add the exponents. I wonder why. In my mind, that makes sense because when we're multiplying, things are growing, but let's kind of see it in action. Let's see. Should we start with variables or with numbers? Maybe with numbers. All right, so let's see. We've got 5 cubed times 5 to the 7th. Ooh, that's kind of big. Let's go a little bit smaller. 5 to the 5th. Now, why do we need to know these rules? Because if we do not have a calculator to use, this is a lot of 5s that we are multiplying. Is going to take a while. So if we're just asked to simplify or rewrite the expression, we just have to simplify it. We don't actually have to find the actual number. So it just wants us to use our exponent rules. So let's think about, what is 5 cubed? What does that mean? Well, it means 5 times 5 times 5, right? You with me? So now let's think of 5 to the 5th. So we're multiplying it by 5 to the 5th. So 5 to the 5th is just 5 more 5s. 5 times 5, 5, 5 times 5. Did I write them all? 1, 2, 3, 4, 5. Perfect. So 5 cubed times 5 to the 5th. Well, how many 5s is that? I keep my base of 5. Notice these rules only work if they have the same base. So I keep my base of 5, and how many 5s total did we have? 1, 2, 3, 4, 5, 6, 7, 8. So that simplifies to 5 to the 8th. Sweet. So instead of having to write that out, I can come down here and think about my rules. If I'm multiplying and I have like bases, all I have to do is say 3 plus 5 is 8, boom, done. But if you don't remember them, you can always come back and write things out longhand. I know it takes a little while, but you won't get it wrong. So let's look at a division problem. So this tells us if we are dividing, we subtract the exponents. So again, let's kind of make up an example. Let's do variables this time. So let's say we've got x to the 7th divided by x to the 4th. So again, this tells, if I remember my rules, I can say, hey, when I'm dividing, I'm just going to subtract. So 7, I want to look at where's the biggest, so there's more on the top, so everything's going to stay on top. So 7 minus 4, this equals x to the 3rd. Let's prove it. In math, they love their proof, so let's go ahead and prove it. So x to the 7th, again, that is 7 x's. 3, 4, 5, 6, 7, 3, 6, 7, beautiful. Divided by x to the 4th. Well, what can I do? Cancel out. Because what's anything divided by itself? 1. By. What are we left with? 3 x's. So again, if you can remember these rules, you do not have to write this out longhand. I'm just proving to you how someone along the line came up with these rules. because they did a ton of these problems and found out, wow, look at this pattern. It happens all the time. Now, this next one. This is where I am super grateful that we have these rules. So if we have an exponent, that looks funny. I'm going to write the E. If we have an exponent raised to an exponent, what do you think the M stands for? You guessed it. We multiply. Okay, so let's say we have, I'm going to use 5 and x. Let's do, oh, should we do something more complex? No, I don't want to confuse you yet. All right, so let's do 7. So I've got 7. I'm going to stick with a variable. Let's do p. So I have p cubed to the 4th. So what does that mean? Another way I can look at it is I have 4 groups of p cubed. So 4 groups, so p cubed, meaning 3 p's, I have 4 groups of those. I'm running out of room. So 4 groups of them, meaning I have how many p's? Well, 3, 6, 9, 12. So it equals p to the 12th. Or the easy way is to say, well, I got an exponent to an exponent, so boom, I'm going to go ahead and multiply. Again, these are just proofs. I'm just showing you why these rules are what they are. So let's go ahead and let's find something a little bit more complex. It says simplify the following. Again, we don't have calculators. We are not using calculators. This whole first semester, we're not using calculators. We need to understand the properties and why things work and how to simplify them without a calculator. So let's look at our first question. -4 r to the 4th, s to the -1st. So there's my first term. And we are going to multiply that by -r to the -9, s to the -1. Beautiful. Now, this looks like a lot going on. So what we're going to do is first we're going to look at what operation are we doing. Boom. Multiplication. Check. Now we're going to break this up piece by piece because, again, these exponent rules only work when we have like bases. Okay? So I'm going to go ahead and break these up term by term or piece by piece. So first I'm going to start with my coefficient. So I've got a -4. Do I have a coefficient here? This just says -r. Well, can I put a number by this? What number can I fill in here? Negative what? -1. So -4 times -1 is 4. Perfect. On to the next one. Now let's look at what our bases of r. So r to the 4th times r to the -9th. Yes, I am using lots of color to keep me organized. So feel free to do that with either pen, highlighter, whatever you got. Once it gets a little bit easier, you don't have to, but at first it really does help when you're looking back at your notes. So again, we are multiplying, so we're going to add the exponents. So I have 4 plus -9. All right, well, I have more negatives, so 4 plus -9, I'm going to subtract. 9 minus 4 gives me 5, and again, more negatives, so r to the -5th. All right, that looks weird, but it's okay. We're going to keep going. Now let's look at our s's. So s to the -1 times s to the -1. Okay, so again, we're multiplying, so we're going to add. So -1 plus -1 gives me s to the -2. Awesome. You have simplified. However, you are not done. We cannot leave negative exponents as a final answer. That's a big no-no. Like you're literally cursing in math if you leave it that way. What? I didn't make up the rules. I just follow them. So what we need to do is keep whatever is fine and then, get rid of our curse words. Clean up that language. So we're going to keep this 4 because the 4 does not have any negative exponents. It has an exponent of 1 if you wanted to write it, but we don't need to. So we're keeping our 4 up in the numerator. Now, r to the negative 5. You are not okay, sir. We've got to get rid of you. So what do we do with it? Well, let's go to another example. Off to the side. So, I don't know. 5 just apparently is my number today. So, 5 to the first is 5. What's 5 squared? 25. What's 5 cubed? 5 times 5 times 5? 125. Cool? Now, find the pattern. Find the pattern between 5, 25, and 125. What's that pattern? I multiply by 5. I multiply by another 5. Does that make sense? We're using powers. So now if we are going to work backwards, what is 5 to the 0 power? Well, don't just assume 0, people. You would be wrong. Continue the pattern backwards. If we're working backwards, instead of multiplying by 5, we're going to divide by 5. So, what's 5 divided by 5? 1. Any non-zero number to the 0 power is 1. It's crazy, I know. But we just proved it. Now, what about negatives? Let's bring in a negative into play. 5 to the negative 1. So let's move backwards one more time. What are we doing? We're dividing by 5 because we're moving backwards. So 1 divided by 5 is 1/5. Well, now you tell me, what's 5 to the negative 2? Move it backwards again. 1/25. Do you see the pattern? Isn't it amazing? So, we cannot keep this negative exponent. It's just not written properly. But what I can do is I can reflect it. And I now have a denominator of r to the 5th. Because once it becomes to the denominator, it now becomes positive because this is technically 1 over 5 to the first, 1 over 5 squared. We just simplified it to 25. Same thing, s to the negative 2. No negatives allowed. So I'm going to drop it to my denominator, and now everything is beautiful and positive, and all is right in the world again. Ta-da! That was a lot, wasn't it? Okay, let's try again. All right, so negative 24, p to the 20th, q to the 12th, divided by 8, p to the 4th, q to the 18th. So, we're going to break it up. First, I look at my coefficients. What is negative 24 divided by 8? Negative 3. So then I have, I'm trying to stick with the same colors, p to the 20th divided by p to the 4th. So again, I am dividing, so I'm going to subtract. So 20 minus 4 gives me p to the 16th. Notice there are more p's in the numerator, so the p's stay in the numerator. Now we're about to get a wrench thrown into the plan because look at the q's. Where are there more q's? In the denominator. So if I want everything to say positive, there's more q's in the denominator. So what's 18 minus 12? 6. So I have 6 q's left in the denominator. If you think about it like that, everything is nice and positive, all my exponents, so we are good to go. We already have our final answer. If you would have done 12 minus 18, that's okay. You would have gotten q to the negative 6. You would have just had to take an extra step to move that q to the 6 to the denominator so that you had a positive exponent. Let me keep my answers the same way. Okay, so now let's go to, I'm going to have to pause my video, so go ahead. I'm out of time. Come back and we'll pick up part 2.